We're looking here at a single phase, split phase capacitor motor, and just a bit of testing before we connect it to a supply. So we'll just start off with an ohm meter and check the resistance of the windings. So up here's the main winding, and you can see down here on the left the ohm meter there indicating that that resistance is about 3.3 ohms. Come down to the auxiliary winding, should be slightly higher than the main, 3.6 ohms. Capacitors will do a static test on those, and of course the normally closed centrifugal switch should indicate 0, so fairly happy with ohms readings. We'll have a look at the capacitor. I've got over here an analog multimeter and an LCR meter. So first up we can use the LCR meter to measure the capacitance of each of these capacitors. The run capacitor down here showing about 78 microfarads, and the start capacitor should be much higher than around about 247 microfarads. So the LCR meter, the capacitance meter, is showing a fair indication for use. We could also do a static test on a capacitor using a analog ohm meter. So we're basically make sure the capacitors are discharged. Just put a shorting lead there across each capacitor, fully discharged, and the analog ohm meter should kick low resistance. Let me get my hand out the way. So looking up here top right at the analog ohm meter, and you can see how it kicks low and then starts to climb up. So you're virtually looking at the capacitor charge up. So the run capacitor looks like it's in fair condition, and if we do the start capacitor, does the same thing, kicking low and starting to go high resistance. So I'm happy with the condition of those capacitors. Short the capacitors just to discharge when finished, and of course we can come up to the meter up here top left, an insulation tester, to make sure the windings and the capacitors are all safe as far as earth resistance. So just checking the meter. Better grab the right leads if I'm going to do that, haven't I? So there's the leads for the meter. The meter's indicating 0 over at that point when I short them together. And the run winding to earth. So I'll go on an earth potential there. Run winding showing infinite. The capacitor dielectric to earth is not moving, so there's good connection there. The centrifugal switch well above earth showing infinite value, not moving, and there we go. So insulation resistance looks pretty good overall for that motor. So we can basically connect it to a supply, being a capacitor motor, and the main winding goes across the supply, active and neutral if you like, and then the same point, that active comes out through a start capacitor we use in this case, through the start capacitor, and then in series with a centrifugal switch, which is then in series with your auxiliary winding. So out of the centrifugal switch back into the auxiliary winding, and of course we need to complete the circuit back to neutral with the other side of the parallel connection to the start winding. So all pretty ready to give that motor a test, and also we can give it a quick tongue test to see what sort of current that it's drawing, so check direction of course. So there we go. So the motor's spinning okay, and it's spinning around that way in a clockwise direction. So a quick tongue test of the supply leads coming in. Let's see, and we can see there we've got about 1.5 amps on that tongue test. So full load of this is about 2.3 amps, and there's no load there of course, so looking like all's working pretty well. Don't forget, if you want to reverse the direction of a single phase, split phase induction motor, capacitor start in this case, we reverse the connections on any one winding. So reversing auxiliary winding, we can see now looking end on the coupling of the motor that it's now going in the anti-clockwise direction. So that's briefly it.